Let me see Alfredo from Clarifai. Come on up, buddy.
All right, and I'll tell you a little bit about us. When we started, there wasn't an OpenAI, but companies were starting to come out and they were doing AI, and we came up with a computer vision API. In fact, you could call an API, it would do computer vision, it would tell you what's in images, what's in videos. As a result of that, we were basically the only game in town, and we had a ton of traffic. We were hitting like billions of requests every month, and so we had to learn to get really good at running AI in production. Turns out that was pretty helpful because right now everyone's trying to run AI in production. Every single company in the world is adding AI into their products and services. We've been doing that for a bit over 10 years. We're quite good at it. And in the past few years, what we've done is we've taken our internal products and we've productized them. So we've made them available so that every company here is able to run AI 2 times faster at half the cost. So we've got 4x more efficient. If you're currently using AWS, if you're currently using Azure or GCP, we can literally save you 50%, if not 75% of your costs by coming to Clarifai. These are real world numbers, and I'm going to talk a little bit about how we do that. Then I'm going to start with maybe what the state of the art is in open source. All right, it's actually one of our go-to models right now when customers say, I need a good model that runs in production. We go to GPT-OSS 120B. Are people familiar with that model? So OpenAI got into the open source game, I think it was late August, early September, and they released this quite wonderful GPT-OSS 120B model. This model can run on 1 GPU, and as a result, it's got the right balance between speed, cost, and intelligence. And so many people, in fact, our researchers always say that about 50% of the revenue that's running on OpenAI really could be running with this model. Okay, so what we'll be talking about is you can power up your agentic AI talking to APIs on OpenAI, on Anthropic, on AWS, etc. But I'm gonna suggest to you that you could be saving up to 96% of your costs. These are real numbers, up to 96% of your costs by using systems like Clarifai's. All right, so let's take an example. GPT-OSS 120B. This is a real-world customer that's using Clarifai. They're using Clarifai's software to optimize this model on NVIDIA B200s. If people are familiar with an NVIDIA B200, that's essentially their best GPU that's out there right now. In 2026, the B300 is going to be coming out. There's going to be new models coming out. But right now, the best GPUs you're able to get is the B200. All right. This customer is seeing 80,000 tokens per second, which if you do the math pretty quickly, and by the way, a B200 has 8 GPUs, right? So a single B200 node will have 8 GPUs inside it. And so you can think of it as like 8 cards where you're able to like flood it with traffic. All right, well, these guys are flooding it with traffic, and we're getting about 80,000 tokens per second. What the heck is that? Okay, well, so to start, 80,000 tokens per second comes out to about 7 billion tokens per day, 200 billion tokens per month, and 2.5 trillion tokens per year, which I'll say are amazing numbers. But let me put that into context a little bit, and I'll do that in 2 ways. So 2.5 trillion tokens per year. The first thing is I'll give you a sense of what is a token and what is 2.5 trillion tokens per year. To give you a sense, a large-ish application that someone builds may have 500,000 lines of code, all right? Not the biggest application in the world, but let's say a large-ish application, 500,000 lines of code. Every line of code will have 10 tokens, okay? So that's 5 million tokens within a large-ish application. Well, okay, so one way to think about it is how many applications that are large-ish can 2.5 trillion tokens per year build for you? And the number is really freaking big. Now, it's not realistic necessarily to say that you're going to have hundreds of thousands of applications being built by this one B200 GPU, but it gives you a little bit of a sense of scale. when you've got an agent that's building your application, it's going to be iterative. You're going to be talking to it. It's going to end up doing a lot more than 5 million tokens to build an application. But it gives you a little bit of a sense. And by the way, if you guys have a sense of how much a B200 costs, so a B200, if you go to like AWS or GCP or Azure, you're probably spending $10 an hour per GPU. That's 8 GPUs per node, $80 an hour. You can do the math. Gets pretty expensive. And so what we're seeing is many people are deciding they're not going to run their GPUs on AWS, GCP, or Azure. They're starting to go to companies like Clarifai. And what we do is we have a network of partners where we get significantly better deals, and we're able to pass it on to the customer. All right, so let me just give you one more sense of scale. So for how much would 2.5 trillion tokens cost you if you were to do it via OpenAI? All right, most of you guys may have used or may be using OpenAI right now. Well, a 2.5 trillion token workload for a year would cost you, on GPT-5, it would cost you about $10 million, okay? Just to give you a sense of cost. So the question is, why would you give OpenAI $10 million? The point is you wouldn't, right? Like in fact, increasingly, as everyone here is adding products and services into your applications, it's no longer reasonable to use companies like OpenAI for your serverless traffic. So that's the motivation. And so we're excited about the future as everyone's bringing products and services, integrating AI into it. We believe that it's critical that you have a cost-efficient, scalable way to run your AI at what exactly means 96% lower cost than you would with OpenAI. So this may be obvious to you guys already, but when you have an agent, every single thought that it does, whether it's reasoning or whether it's generating outputs, is a token. And so maximizing the cost of a token, the performance of a token, is absolutely critical. And the problem with these agents is they are token hogs, right? Like they think so much. And part of the way they're so smart is they're constantly thinking, and every thought is expensive. And so being able to truly use agentic capabilities, you need a new paradigm for how you're running these things in production. I'm not going to go too deep into what Clarifai does, but I will tell a couple things that we focus on that we've decided are important, okay? And that is being multi-cloud and multi-infrastructure. So what does that mean? Everyone here is probably using one of AWS, GCP, or Azure. We support that. If you need to be able to load your workloads on AWS, for example. In fact, if you use Clarifai's version of AWS's B200s, we're still going to be 3 times faster than AWS. So on Azure, we are 2 times faster. On GCP, we're on 2 times faster. AWS, if you guys are out there, I love you guys. You're great. But their inference offering could be a little better. Okay, so for us, it was important to be able to go across all the clouds. And we also work with a bunch of other partners. So any neo cloud that you can think of that offers basically better priced GPUs. We give you one API. You can set up your workloads on any cloud, on any GPU, and we make it work for you pretty seamlessly. All you have to do is connect up to your API. You stream the responses. You don't have to think about that. So that was one thing. The other thing that was important beyond multi-cloud for us was architecture, you can call it. We support NVIDIA, AMD. We're going to be announcing other stuff soon that'll be exciting. But for us, it's really important that there isn't one monopoly on accelerators. And so from our perspective, it's critical that we're able to offer the best price and the best performance, and being able to help people switch between AMD and NVIDIA, for example, is a core part of what we've built. And to give you a sense, the customer that I was talking to you about, they've got about 32 GPUs in production. It's a medium-sized load. You know, depending on what you guys are doing, you may be doing a lot more than that. You may be doing a lot less than that. But if for some reason they launch a product and their capacity gets flooded, then they're going to need more than 32 GPUs. And so you need to be able to scale beyond that. And that's where we've implemented what we call compute orchestration. So compute orchestration allows you to take a GPU and allows you to fraction it. Okay, so think of it as a B200 has 190, either 92 or 96, 192, 96, I don't remember. Someone will know here probably more than I do. And so you can take that memory and you can put multiple different models on it. You can put your 20B model, your 120B model, your 8B model, multiple different models. And so that rather than basically having this paradigm where you've got one model per GPU, you're able to share your GPU across multiple different models. So that's one thing that helps you optimize costs. As you get more traffic, you need to be able to auto scale. So you get a burst of traffic, you need to be able to bring up more nodes without having any downtime. And so we do that, and we can do that not only within the cloud that you're using, but we can scale you from one cloud, and then you run out of capacity in this cloud, we'll help you scale up new nodes in another cloud. We can scale you on NVIDIA, and then you run out of NVIDIA capacity, we'll scale you on AMD. All of these things you never want to build, we've built it for you. And the intent is to make it so that people are able to serve inference, again, 2 times faster, half the price. Many other optimizations that we've done, we've run this at multiple scales, and what ends up happening is essentially you talk to our control plane. You have an API that you're able to hit, and our control plane is able to then talk to compute planes that we manage for you anywhere, whether it's AWS, whether it's Lambda, whether it's Vultr, etc. The other thing that's pretty cool if you're a developer, there may be some developers in this room, is actually having a really great developer experience. And so if you actually want to be able to run your model on your laptop, for example, we have this thing called the local runner. Basically, you just use your favorite client, whether it's using the OpenAI specs or whatever favorite SDK you're using, whether it's LangChain or Llama Index or Vercel. We're available, actually we're about to be available, hopefully today, on OpenRouter. And so there's many ways to connect to us, but you can speak to one spec. You can run your model on your laptop. You can add debug code into your model on your laptop, and we give you a web interface where you're able to talk to your model just the way that you would as if it were in prod. You type one command, it pushes it to production, and now you're sitting in a node pool that's customized for you with an uber efficient experience. We also did this thing called the Clarifai reasoning engine. So Clarifai has multiple different PhDs that have joined Clarifai for quite a while. And frankly, if you want to beat the best performance out there, I'm not even joking. I'll show you some numbers. Like we literally are 3 times faster than AWS, 2 times faster than Azure and GCP. If you want to be able to get those types of speeds, you can't just take the open source packages that are out there, VLLM, SGLang, TRT. You can't just take those things. You have to be able to optimize it. And so our researchers go into these packages, take the best from all of them, and we've put together our own toolkit called the Clarifai reasoning engine that helps us get this level of performance. And so people will ask, well, how do you actually do that? How do you actually optimize this? Well, it's actually a ton of stuff. Things like making our own CUDA kernel, if you're familiar with NVIDIA CUDA, or making our own kernels to be able to do things more efficiently and being more efficient around how you use the server. Moving code from Python to C++, optimizing the tokenizer so that you're using the routines that are the most efficient, batching stuff, pooling memory together. And we've also implemented something that we just call adaptive learning or adaptive intelligence. Essentially, as your workload starts to resemble itself, if, for example, you have a type of workload that sends similar things, it'll learn from it, and it'll take KV caching or caching to another layer, and it's able to get some really significant boosts in performance. So then people say, like, yeah, everyone says that, prove it. So the proof is pretty simple. There's a company called artificialanalysis.ai. Artificialanalysis.ai is what we think the standard around benchmarking AI in production. And so artificialanalysis.ai, today, if you go to today, right now, if you check it out, you'll see that Clarifai is the fastest, right? So it's the highest on the y-axis, it's the fastest. And also on the x-axis is the cost. So you want to be near the left. You can see where Google Vertex is. I love those guys, honestly, really do. Azure, AWS, others. But we are proud to say that we're doing some good work. We're doing some good work, and we're helping people implement AI inference at truly impactful numbers. We're not talking about saving 10%, 20% here. We're talking about literally 4x efficiency improvements. Some of the customers that are using us, one company, RC, they are trying to be the DeepSeek of the West. Right. In fact, if you ask me, like, what are the models that people are using the most on your platform, OpenAI, GPTOS is one of the big ones, but DeepSeek is another one that we see quite a bit. Actually, Clarifai has done a lot of work with DoD and intelligence. We've had to deploy in very secure environments. They will not use DeepSeek, right? They don't want to use Chinese models, as good as they are. There's a need for open source solutions. RC is a company that's building on top of Clarifai. And in this particular case, they tried us out of the box without doing any of our optimizations. And out of the box, we were 65% faster at time to first token and 40% faster overall. That's before they deployed the Clarifai reasoning engine, and so we'll have some interesting announcements with them in the next little bit. Miro, you may have heard of, is a great kind of a diagramming tool. And we've had some good experience with them. And Parada is a kind of I think it's like a Series A startup. I'm not sure what series they're in, but they came to us and they had benchmarked Together AI, they had benchmarked Fireworks, they had benchmarked their own internal stuff. And we were, at the time, about 25% faster. Now we're actually about 100% faster. Okay, that's it. My whole pitch to you is that there are more efficient ways to run AI at 4x efficiencies, 2x faster, half the cost. If you're interested in learning more about that, or just talking shop, please reach out to me. We've got a booth outside and happy to chat. Thank you so much for your time, everyone.